wish you said microphone.
Okay, so this is lesson 5A, am I a function? We're going to be talking about what a function is. We define a function as a relation in which each element of the domain being x, is paired with exactly one element of the range, which is y. Remember domain and range? We went over it together because you guys said you didn't know what it was. Well, now you know. Okay, so using your array tool, go to the next page. Using our array tool, we're going to map the following relation so that it is a function. Okay? So everybody go down to this section of their page. Remember, that's Control-Tab to get down to the other section. You there?
Yeah.
Okay, so I want you to hit your menu button. Okay? And what you're going to do is you're going to go down to points and lines.
I didn't mean to.
Are you on the bottom half of the page, Joey? So you want points and lines. Click on it, and it should bring up a bunch more options. See it? You're going to go down to 6, which is ray. What this does is it allows us to make rays on our paper, okay, or on our calculator. So what you're going to do is you're going to bring your pointer over to the first number, and what I want you to do is I want you to map from one to the other what you think a function is, okay? How you would match it up so that it would make it a function. So if you don't remember, let's go back a page. That each element of the domain x is paired with exactly one element of the range y.
So it's
Domain, range. Okay, so I want you to use your array tool to put them in there and see if you can make a function.
pretty much doesn't matter.
So what you do is you click next to the number, you drag over to the other number, and it should make a ray. Did everybody get it? This tool does not turn off until you turn it off. So you can use it again without having to go menu, tools, okay? You'll be able to use it each time.
That one's crooked.
It's okay if it's crooked, it doesn't have to be perfect. Okay?
There's no right answers. Are you supposed to make lines for your class?
However you want to do it. No, this is just, I'm just showing you how to use the tool. You figure it out the way you would normally do it. How'd we do?
How do you know we did it good?
Well, let's take a look. Next page. Does your function look like mine?
Oh.
It may not look like mine, but does every number go to one other number?
Yeah.
Yeah.
Okay, then that works.
So
You can't have an x value domain that repeats.
Is this one okay?
Okay, you can't have an x value that goes to two numbers. Can only go to one.
if I got -2 going to 3, that's okay.
That's fine. You just can't have one of these numbers going to two different.
I can go 4 and 1.
Right, exactly.
Can I make one of the ones on the right go to the one on the left? I don't
Well,
care.
it would still the left be going to the right. It works both ways.
I know
So
what
a line's a line.
Okay, right, a line's a line. All right, so let's look at the next page. What did you notice about the function?
Each one has
Each one goes to 1.
another one.
Each one goes to one. So however you're going to remember it, I want you to type it in here. Okay, however you are going to remember it, you're going to type it in there. Can't have any x value that maps to more than one y. All right, so let's look at the next one. Could we also determine if a relation is a function by using a different notation, such as this? What are these? They're coordinates. Okay? So this is another way to look at it. We just looked at it as two sets, domain and range. Now we're looking at coordinates. So what is it that we are looking for?
See if the x value repeats.
To see if the x value repeats. So down here I want you to write, see if the x value repeats. Very good, Dan. All right, so we decided that what we were looking for is the x value cannot repeat, right? Any issues with that?
There aren't 2 words. Are you wondering? C-A-N,
Yeah, I don't know.
Yeah, it is.
It doesn't really matter, does it?
You have to say it works this way.
Works as two. You could also say can't. Then you could write it as one.
That's not proper though.
I'm sorry, I'm not proper. Next page. Okay, so is this relation, what?
I have no idea.
Is this relation a function?
No.
Okay, click false. Why is it not a function?
Sixes.
Wait.
Don't tell me the
It's
sixes.
because of the fours.
The
Y
fours.
value-
Oh,
yeah,
fours.
yeah.
The y value can repeat, the x value cannot.
Oh.
Okay?
Can we
So
write why it isn't?
if you like to, you kind of just told me that the page before, but you can write it again if you wish. Alright, so let's look at the next one.
What was that, false?
Yes.
This is
Okay,
what-
this one is a function, this one is not. You cannot have any repeating x values. That's the most important part. Okay? So this is a function because I don't have any x values that are repeating. This is not because we see my one repeat. Any problems with that?
No.
This is easy stuff, right? Alright, let's look at the next page. Okay, so let's think about this relation here. What else could we do with these quote-unquote numbers? Here's your hint. Yeah, correct. Okay, so go to the next page. And what you're going to do, I'll write down the numbers over here so you guys don't have to flip back and forth, is we're actually going to graph these numbers. And our calculator has a nice tool for us to use when we want to graph points. Where do I find it, do you think?
Menu?
Menu. Go to your menu. Good. No?
Points and lines.
Say it again. Dan?
Points and lines.
Points and lines. And you want
Point.
a point. Okay, and you're going to put in your points. -1, 7. See how I have the grid on there for you so you can count? It's okay. Remember, you don't have to keep turning on the tool. The tool stays on until you hit escape.
That's-
Okay, so everybody has them plotted, correct? All right, now what we said was that we can't have any x values repeated, right? So where are my x values along this graph? Where do they lie? On the horizontal, and this is what we call the x-axis, right? So if we can't have any x values that are repeating, what are we looking for? What can't we have happen when we're looking at it graphically?
A line and vertical.
Say it again.
2 points that are vertical.
2 points that are vertical. So if I were to take a vertical line and pass it through here, I couldn't have a line where we would have more than 1 point hit it. Is that happening here?
Yes.
Yeah.
Yeah, look here, right on the y-axis, I've got those 2 points. So was that a function?
No.
No. Very good.
Is that called vertical line?
It is called the vertical line test. Yes, very good. So what do you notice about where the points are in relation to each other and in relation to the x and y axis? What you're going to do is you're going to put in how you're going to remember this. How you're going to remember it is vertical line test. Excellent. We're already past that point. So whatever the way you're going to remember it, remember Control Tab to get down there. Type in your hint, how you're going to remember it. Okay?
I like
Okay, so was our relation a function?
No.
No. No, it was not.
What you
That's
just
on the next
discovered was
page.
vertical line?
All right, so what you just discovered was the vertical line test. Some of you already got to that point. That's awesome. In your own words, explain to me how the vertical line test works. So bottom half of the page, in your own words. Okay, so we talked about the vertical line test. We talked about different ways we can view these functions. Let's actually look at an example of this. All right, so the next page we have a graph. We're going to determine if it's a function by using what you've learned. Use the point on the vertical line to transform the line along the x-axis. So go to the next page. You see my point here? What you're going to do is you're going to go over, bring it real close to that point, and you should see a little hand pop up. Okay? You're going to bring your cursor next to the point until you see your hand pop up. See the hand where it looks like it wants to grab it? Do you guys remember how to grab a point? Control, click. It'll grab the point, and what I want you to do is pull it back and forth along this x-axis.
So crazy.
So you should be able to grab it and then pull it back and forth. And what this is an example of the vertical line test. We want to know, using this vertical line, can we tell if this is a function or not?
Yeah.
Why do you say yes?
Passes the vertical line test.
Yeah.
Passes the vertical line test. This vertical line doesn't pass through the graph any more than one time at any place. Okay? Does that make sense to everybody?
Yeah.
Good. Go to the next page. So, question, is this graph a function? Describe how you arrived at your answer. So you are going to answer down here. Somewhere, right down there.
Well, I strongly agree.
You say yes?
Yep. And we arrived at the answer because when we passed the vertical line through the function, it didn't cross in any place more than once.
Getting better.
Yeah, it gets faster.
Type it in. I strongly agree.
Okay, so the last part of this is, did this document help me understand when a relation is a function? Strongly agree, agree, neutral, disagree, or strongly
I
disagree?
strongly disagree, but I agree.
You what?
I agree.
You agree. Okay, so you put your answer in there. Okay, so we're good with this, right? I'd like you all to open document 5B now.
I'll even use exclamation.
Okay, we're talking about direct and inverse variation. This is where we're going next. Alright, so go to the next page.
Okay.
Alright, so this is the definition of direct variation. It's when two variables are directly related if the ratio of their variables always remains the same. And you'll see what this means in just a second. Okay? So of the equation of form y equals k times x. K is the variable, is what we call the constant of variation. Okay? So what we're going to do is we're going to use the slider on the next page to observe the changes in the line as the value for k changes. So let's go to the next page. Okay, see the slider here? You're going to bring your cursor up. You're going to grab onto that slider and you're going to move it back and forth. And what I want you to do is look at this line as we move the slider. Look at what's changing here. Look at what's changing for k. Yeah, they're both changing, right? So what are we changing? What is the value of k changing?
The slope.
The slope. Does that make sense to everybody?
Yeah.
So that constant of variation is our slope that's changing.
Oh, so it's positive. Alright.
Do we get that? Does everybody see how it's changing? We're going from a positive slope, and then when we got through that, we're going to the negatives, we're dealing with a negative slope. Are we okay? Alright, let's look at the next page. What happens to the value of y as x increases? Or how about as x decreases?
What's x?
Slope increase.
Is X?
Is x the same thing as k?
Yeah. Well, look at our y. Here's our y values, okay? This is where they would be. Watch your slope, okay? Slope is down here. This is where your y is. As I increase the slope, is your y getting bigger or smaller?
Bigger.
Bigger. As I decrease the slope, what's happening to your y? It's decreasing. Okay, so increase the slope, y increases, decrease the slope, y, what did I just say? Yeah, you're good.
So the
Alright.
answer would be F.
So as x increases, y increases. As x decreases, y decreases.
So how are we supposed to get to this?
You're supposed to finish all this.
There's like 4.3 pages.
There's like 5.5. What do you mean?
Oh, okay. About that like 11 pages.
But a lot of it is just this kind of playing with the sliders and things like that.
That's fun.
So
It's not.
All right, so let's look at the next page. What do you notice about the y-intercept of the line? Let's go back. What do you notice about the y-intercept of the line?
So much time to talk.
Does the y-intercept ever change?
No.
Okay, so what do we notice about the y-intercept of the line?
Same.
The y-intercept stays the same, or the y-intercept is always 0. So I would put in always 0.
Wow. That's something new.
Oops. Oops.
So you can type pretty fast on these calculators?
On the calculators, but not up here. It's too hard to see.
Oh yeah, that looks like it'd be hard to hit the button.
Okay, so when does direct variation line have a positive slope or a negative slope?
When K is positive.
When K is positive, it's positive, and when K is negative, it's,
Negative.
so that's what you want to put. K positive, it's positive. When K is negative, it's negative. When K is positive, it's positive. When K is negative, it's negative.
That's fun, Michael.
Oh crap. All right, so got that. So when K increases, the slope increases. When K decreases, the slope decreases. For what value of K does the direct variation model not appear on the screen? So go back to your graph and take the slider and move it around. When do we see that it doesn't appear? When K is 0, when the slope is 0. Okay? So when we're going to say 0 here. And it's 0. Why? There's no slope. Where is it? Where is that line?
on the x-axis.
It's on the x-axis. Very good. Okay.
So we put 0.
0.
Because
Yep.
there's a slope.
Because there's no slope. 0 because there's no slope. So although there's a lot of slides here, guys, this does go really fast. But we're not going to get through it all.
You only get like halfway there.
I like this stuff better because it's tall grass and stuff. And it's so fresh in my mouth.
Good. All right, so how does the constant of variation, that K, how does it affect the graph? What does it changes the slope? Very good.
Oh, we got it.
I mean, that was so another.
Where do you get all this stuff from, Margarita?
It changes the slope. Okay, so here's an example of direct variation. Direct variation is how much an hourly employee gets paid. His or her total paycheck is equal to a certain wage. Does that make sense?
Yeah.
Okay. Multiplied by the number of hours they work. So pay equals the wage times the number of hours worked. P equals W times H. No problems with that, right? Okay. So let's look at the next page. P equals W times H. In the equation P equals W times H, which letter represents the constant of variation?
None, they all vary.
So careful.
H and T.
Actually, it's W, not
It's
A.
W. Why is it W? Look at how it's set up.
Your wage is always the same.
Your wages is always the
Depends on
same.
what type of dirty work you do. That could pay different.
What's constant mean?
Doesn't change.
Doesn't change.
Oh,
You can work different hours.
Right.
You
Well,
can
that's
work
a
different
variation.
hours, your wages never
So
change.
constant of variation is something that doesn't change. It's right in the term. Constant doesn't change. The only thing that's not changing is W. That's your wages. Okay? Okay. We're going to rewrite the wage function. If the employee is being paid $6.50 an hour, how would I write this?
P equals 650
Okay,
times
ripped up.
H.
Very good. Excellent. Any problems there?
Feels like we're all smarter today.
Okay. Rewrite it if it's $9 per hour.
Equals 900.
Good. Any problems with this? Didn't think there would be.
That's a good paycheck.
$9 an hour?
12.16.
Switch to now, I'm 16, I was like $20 an hour. That's just stupid.
You should just
All right.
One.
All right.
Oh,
Okay.
Okay, so,
You could just be like, all right, guys, for the first hour, I want you to try to figure out the calculator.
okay, on the next page, we're gonna set the wage at $6.50. How much does the employee earn for 26 hours?
I'm just getting that much.
How'd you get it?
I multiplied them.
How did you multiply them? You got,
657 times 26 hours.
so she got 169. Any problems there?
we don't get math on this thing.
Yeah, we don't.
You don't get math on this thing?
Like we can't type it in unless we don't have.
Well,
a
what we're actually gonna do is we're looking at the next page,
What is it, 1.9?
okay? We're looking at the next page. So, if W is his wages, right? We're saying that his wage was $6.50. Stop talking while I'm talking it through. So here's $6.50 an hour. Okay, we're actually using this graph to do this. She did it algebraically, that's perfectly fine, but it can also be done graphically. So here's $6.50 an hour,
Can't grab this.
I like that.
and we want 26 hours.
Are you doing control?
Why is this giving us 170?
It's giving me 168 on my.
I wonder why. Should say 169. I don't know why mine's off.
Well, maybe I spent like $1 and you earned an extra $1 because you found out the ground.
Well, I shouldn't have that problem.
It says 26, 170.
I'm not sure. Yeah, it should say 169. I'm not sure why it's
Mine
doing
says
that.
168.
Okay, the employee earned a raise in $7.10 per hour. How much would he or she get paid for 22.5 hours of work? So let's go to the next page. What did we just say the amount was? $7.10. So move your slider to $7.10.
Should be 159.79.
It should be $159.75. I don't know why my slider's not working.
My slider's not working now either.
Yeah.
My slider.
When I went to go back to the next page, it said invalid something.
It's all very upsetting. I'm not sure. It was working
Say
before.
we got paid more and we worked less.
I am sorry, my slider is not working. But algebraically, you got what? 159.75. Does anybody have any problems with direct variation? This is easy stuff, right? We know that it's just multiplication.
Are we at inverse variation now?
We are going to inverse variation.
We just started new topic.
So what I need you to remember for direct variation, it's multiplication. That's it, multiplication. Y equals mx.
Plus B?
No, okay?
Logic.
All right.
Andrew will tell you
Control editor range.
So let's talk about inverse variation now. Come on, we have 10 minutes to do 50 more pages. Quiet. All right, inverse variation. Two variables are indirectly related if their products of their values always remain the same. So what it looks like is y equals k divided by x. So instead of k times x, the inverse of multiplication is k divided by x. Okay, so this is what inverse variation is. Now, a lot of times they'll put these on the Regents exams. They'll ask you which one's inverse variation, and this will be the only one with division. That's 9 times out of 10 to 1. Okay, or x times y equals k, because if you divide over the x, you get the same thing.
Okay, same thing then.
K is the, in my last example, yes. Okay,
I really want
k
to
is the
learn all
constant of variation. What?
We won't have to do a lot of these because they won't be on the reading sample.
It will, you might have one, maybe two, okay? All right, so use the slider on the next page to observe the changes in the line as k changes. Are you ready? Here's our slider. This is an example of inverse variation. These look funky, right? This is called a hyperbola.
Oh, I love hyperbola.
Hyperbola.
Let's taught us that word.
Okay, so grab your slider. You're going to change k. Watch what happens as you change k. Where do we see a shift? Right over that 0. You see how it goes from quadrants 1 and 3 to quadrants 2 and 4?
That's great. So it's
What's this
positive.
creative?
If it's positive, they're in
Quadrants 1 and 3.
1 and 3, and then if it's negative, they're in 2 and 4.
Yeah. Okay.
Is that always going to be true?
Yeah. Okay, so let's ask a couple questions with this. Now, I want you to keep moving that slider. I'm going to ask the question before you turn the page. Are you ready? what happens as the value of y, what happens to the value of y as x increases. So here's your x value.
Value of y increases.
Here's your x and y. The value of y decreases and the value of y increases. These are not good questions. I don't like this question.
So we're
All
gonna
right,
start opposite.
what I want you to see, yes, is how as you increase the constant of variation,
So bring it right.
see what happens to it as you increase the constant of variation? How this lifts up away from that x-axis or below it. And as you get closer to 0, it gets closer to that x-axis. See how close it gets right there? Real close.
Once you get at 0, it disappears.
0 disappears because if it's 0, do you have a function? No. And as you go negative, it switches over. Okay? So let's skip this slide and I want you to go right to the next one. 3, 4. Okay, in what quadrants does the graph appear when k is positive?
2 or 4, or 2 or 3.
1 and 3. And
Oh,
negative?
I forgot it goes 1, 2, 3.
What about negative?
2.
2 and 4. Okay, get those in there. So quadrants 1 and 3 when it's positive. Quadrants 2 and 4 and negative. So what I'm going to do is just say 1 and 3 and then a plus sign. I'm going to shorthand everything here. And then 2 and 4 when it's negative. Instead of typing it all out. All right, so what values of k does inverse variation model not appear on the screen? 0. Why?
Sorry, function.
Hmm?
Sorry,
Yeah,
function.
0, when you multiply anything by 0, 0 goes away. Okay?
What are we doing for 3, 5?
3, 5, 0.
0. Why do you think this is?
Why do you think it is? Because when you multiply anything by 0, it's 0, so you can't graph y equals 0. It's on the x-axis. All right, so how does the constant of variation k affect the graph? I'm going to give you this one. Okay, k affects the distance of the graph from the origin. You guys know what the origin is?
Yeah.
It's the point 0, 0. Okay, so it affects the distance of the graph from the origin and the quadrants in which the graph appears. So here's your graph. Watch the origin. You see the origin? See how close we get? And as we move the slider, it gets further and further away. So the distance from the origin and what quadrants in which it appears.
So what are we supposed to do?
Distance from origin, quadrants, it shows up.
2.6?
Yes, sir. So the distance from the origin and the quadrants in which it appears. You getting this, John? What's your calculator asleep?
Yeah.
Distance from origin, quadrants in which it appears.
So you teach like other teachers how to use the calculator?
I do.
That's like if we went to college and just had things.
Ooh.
Okay, so for salaried employees, the amount that he or she earns per hour is inversely related to the number of hours she works. He or she earns a fixed amount per week regardless of how many hours worked. Does that make sense to everybody here? Okay. All right, the amount an employee earns per week is equal to the amount earned per week divided by the weekly number of hours worked. Make sense?
Yeah.
That's nothing new. Okay. So in the equation, R equals S over H, which letter represents the constant of variation? S. That's the salary. It's not going to change. Any problems? Good.
We got
Okay.
pretty far.
Yeah. Okay, rewrite the rate function. If the employee is being paid $900 per week, how am I going to rewrite it?
Sorry, right there over H.
Perfect. R equals 900 over H. So use your fraction template.
I like when we use that lesson.
And then do the same thing for 650 per week.
So we're gonna be able to do all of our homework.
I
Here goes 900
feel
over.
very confident about this lesson.
Yeah, I feel like this lesson is a lot easier than what we did at the beginning of the year.
Yeah, it kind of boosts my morale a little bit.
I have more faith in my ability to pass this class.
On my desk, filling out. Okay, so homework for tonight is homework 5. It is on your calculators. Please remember that weekly project 1 corrections are due next class, as are your quiz corrections. If you do not have them next class, I will not be accepting them late.